In this tutorial, we are going to learn how the full adder logic circuit works. The logic circuit of the full adder looks like this. So it consists of two XOR gates. It has two AND gates and one OR gate. It has three inputs, A, B and carry in, and it also has two outputs, sum S and carry C. So to simplify the full adder logic circuit, we use what is called a block diagram. So the block diagram also has three inputs, A, B and carry in, and it also has two outputs, sum S and carry C. The block diagram is the equivalent of the logic circuit. The only difference is that the circuitry of the logic circuit is basically inside the block. However, because we are only interested in the inputs and outputs of the adder, we can disregard the circuitry. Instead, we just call the block full adder. So the full adder is what we call a combinational logic circuit. Because there are three inputs, there will only be 8 different combinations. Now, to find the 8 different combinations, we will use a 3-input truth table. To understand truth tables, just go back and watch my video on them. So anyway, let's quickly go through the combinations that this full adder 3 combinational inputs can have. So we could have, it could be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, or 1, 1, 1. Now to find the outputs sum S and carry C, we use 3-bit binary addition. To fully understand this next part, watch my video on binary addition. So looking at the first row of inputs on the truth table here, let's look in more detail. So we're taking the first term, 0 plus 0 is 0, and 0 plus 0 is 0. So the sum is 0, and there is no carry bit. So carry out is 0. So again, the first term, 0 plus 0 is 0. 0 plus 1 is 1. So the sum is 1, and then there is no carry bit. So on the next, 0 plus 1 is 1. So 1 plus 0 is 1. So the sum is 1, and there is no carry bit. So 0 plus 1 is 1. 1 plus 1 in binary is 0, and then you get a carry bit. So we take the sum still is 0, but then we have a carry bit, so carry out is 1. Let's take the next one. It's quite an easy one. 1 plus 0 is 1. 1 plus 0 is 1. So the sum is 1 and carry out is 0. So 1 plus 0 is 1. And then 1 plus 1 again is 0, and you get a carry bit. So the sum is 1 and carry out is 1. So 1 plus 1 is 0, and you get a carry bit. 0 plus 0, so you don't carry the bit over to this bit. What you do is you do 0 plus 0, and the bit is carried over. So the sum is 1 and carry out is 1. So let's do the final one. So the first term, 1 plus 1 is 0, and you get a carry bit. And then 0 plus 1 is 1, and then you still have the carry bit. So the sum is 1, and carry out is 1. So the full adder is basically a combinational circuit that computes the addition of 3 bits. So the binary addition is here. What we just did is how the full adder logic circuit works. So you have the inputs, and then this binary addition inside this box, and then the two outputs. If you'd like to know how to design and build a full adder logic circuit, click here.